On This Week in Enterprise Tech, it's a special year-end episode for you, and this is quite the year for TWiET. We've taken some of the best moments of 2018. We put them all in one big episode for you to listen to and enjoy. It's the best of 2018. TWiET on the set.
Netcasts you love.
From people you trust.
This is TWiET.
This is TWiET, This Week in Enterprise Tech, episode 322 for December 28th, 2018. Best of TWiET 2018. Welcome to TWiET, This Week in Enterprise Tech, the show that's dedicated to you, the enterprise professional, the IT pro, and that geek who just wants to know how this world is connected. I'm your host, Louis Maresca, your guide through this big world of the enterprise. And this episode, we have quite the treat for you during this holiday season. We have the best of 2018 for TWiET, and we've taken some of the best moments of 2018 and put them all in one episode. And so without further ado, let's jump right in.
Let's say I'm running a more traditional enterprise, and I'm just starting to migrate my infrastructure into the cloud. And I start hearing about microservices, and my IT guy is coming to me and saying, well, we should start thinking about this. What changes do I need to make on my internal team that has been developing huge applications over, the course of decades, where I'm now going to say, well, instead of one big dev team, I've got 40 dev teams, and each are responsible for this little bit and piece of an app that they need to create, following the rules of the API. What are some of the biggest mistakes that you've seen when companies move into that? And then what are the ways that they can avoid those mistakes?
Yeah, that's a great question. So I think there's two big mistakes that they make. One is not changing the org at all and trying to approach these techniques. There are changes in how teams work that have to be adopted. And the second mistake they make is doing it all at once. Looking at their big environment and saying, okay, well, I'm going to change this from one monolith into 40 microservices and create 40 teams and do that all on day one. Because that's just not going to be successful for most people. You got to start somewhere, start small with one or two services that extend or add on to the side or change some component of an application that you have today. But for that starting point, yes, you have to build a team that can own that service end to end. I think one of the really important ideas of microservices is that the team that owns that service owns the entire lifecycle of that service. They build it, they test it, they deploy it, they operate it, they can change it whenever they need to change it as independently as possible from everything else going on around them, which is why things like APIs are so important. I look at ourselves. I mean, IBM, we're pioneering a lot of these ideas, but we also apply them to ourselves. And, we're a big enterprise that's been around for a long time. So we have a lot of the same transformation challenges that a lot of our customers have. And one of the first things we did in our journey around IBM Cloud is we created a new model in how we organized our teams. And we created what we call tribes and squads that was modeled after how Spotify does their development. And the idea with tribes and squads was exactly that, to have co-located teams that owned a service end to end, right? And that was not how we were organized before. And that's been, I think, really critical to being successful. So when I go talk to clients, we talk to them not only about our platform and our technologies, but also how they can transform their development practices to be successful in exploiting these things.
All right. Cheever, is this something that you would use on your campus? Because, it sounds like it's right up your alley.
Yeah, actually, I've got a problem that I've got more data than I know what to do with. So that's one issue. But I've got hundreds and hundreds of hours of streaming video coming off our subs, our underwater cables, and our ROVs. And we'd love to have a way of recognizing species, but also making it so that we could have different research groups do different types of analysis on the data that's coming in, both acoustic and video. So I guess the question is, from that kind of standpoint, what kinds of things do I need to start looking at to try and adopt microservices? And more importantly, how do I integrate, say, Watson in there to do things like fish oceanographic species identification from my video streams?
Yeah, it's a great scenario. And in fact, one that we've felt is, really fertile area for applying Watson. We, in fact, have a video unit as part of IBM Cloud that specifically enables kind of live streaming and video applications as part of our cloud platform. And one of the things we've been doing is exactly what you're describing, which is applying some of the image and video recognition capabilities of Watson to those video applications. So we can, you can do simple things like auto tag videos with what's in them, what kind of objects and stuff, so you can do better search. And that's all trainable. Like we have a customer who's doing something similar to what you're describing, which is they're using Watson to do maintenance of cell phone towers. So instead of sending a person to climb a tower and determine if there's any maintenance issues with that tower, they're flying drones around the tower, doing live video streaming off of the drone, feeding the video streams to Watson, and they've trained Watson with imagery about maintenance problems. Like, this is what rust and maintenance faults in these towers look like versus good towers. And that enables that application to automatically identify towers that might have problems without having to send people up there. And so I think the scenario you're talking about is similar, where you could take those video streams of underwater imagery, train Watson on species that you know about, and have Watson identify those species, or at least identify interesting segments of that video that would have further analysis. So, those are great scenarios that, these platforms are designed to help you build. Right?
I think that clears it up for a lot of our audience there, then, in that the applications for which microservices are best are those applications that deal with very complex problems that can be broken down into small component pieces. Anytime you can do that, that's a natural fit for a microservice.
Or an application that's changing a lot, right? Precisely. One that has a high rate of change.
Precisely. Well, that's a very nice way to look at it. And you know what? It's nice to have someone who can come in and actually explain something that has been a buzzword for a lot of people. And microservices now is what cloud computing was 5 years ago.
Meltdown Inspector there last week. As it turns out, EMC and VMware want to get into the security oops action as well. Now, while everyone was screaming about Meltdown Inspector, another urgent security fix was already in progress for many corporate data centers and cloud providers who use products from Dell's EMC and VMware units. A trio of critical, newly reported vulnerabilities in EMC and VMware backup and recovery tools, that's EMC Avamar, EMC Networker, EMC Integrated Data Protection Appliance, and vSphere Data Protection, could allow an attacker to gain root access to the systems or to specific files, or inject malicious files into the server's file system. These problems can only be fixed with upgrades. The first of the vulnerabilities, designated in MITRE's Common Vulnerabilities and Exposures, that's the CVE list as CVE-2017-15548, allows an attacker to gain root access to the servers. This would potentially give someone direct access to backups on the server, allowing them to retrieve images of virtual machines, backed up databases, and other data stored within the affected systems. The second vulnerability, CVE-2017-15549, makes it possible for an attacker to potentially upload malicious files into any location of the server file system without authentication. The third, that's CVE-2017-15550, is a privilege escalation bug that could allow someone with low-level authenticated access to access files within the server. The attacker could do this by using a web request crafted to take advantage of path traversal. That's moving up and down within the directory structure of the file system used by the application. These attacks all require access to the network that the servers run on, so it may not be possible in most cases to execute the attacks from the internet, at least if the backup systems are running in a network partitioned from the internet. But in these vulnerabilities, you could create opportunities for attackers who've already managed to get a foothold in data centers via other exploits to take further advantage. And unfortunately, as security researcher Davi Ottenheimer pointed out, there are hundreds of these systems exposed to the internet, including more than 100 of them in Ukraine, China, and Russia. Now, I want to bring in my co-host on this. Cheebert, the first thing we need to realize is that with these vulnerabilities, no passwords are required to access the backup data. Now, I have to ask, in your experience, are most people doing a good job of password protecting backup data, or is that in itself sort of a processed level vulnerability that exists in a lot of places?
I've seen way too many people not password protect backup data sets only because they're paranoid. You know, we've seen a lot of cases where, you know, tapes or whatever backup medium you used had a slight glitch. And with encrypted data or password protected data, sometimes you can't do a restore. Well, all too many people say, no, I don't want to take that chance. I'll just rely on physical security. So that's all nice. Now, I will need to point out, this requires that you be on the local network of the files of the servers. So if you are, sadly, making that management network available to the world, don't. Also, there's a lot of people freaking out about Meltdown Inspector. Both require physical access. So to the other people, you know, in the mainstream media, chill, guys. Come on. This is not the end of the world. You have time. It requires physical access, or it requires access to the network. Just patch. Again, I think this is more a case of it's got a cool name and it rolls off the tongue, and mainstream media is saying, hey, if it bleeds, it leads, right?
Absolutely. And let's never underestimate the importance of a really scary name when it comes to giving a vulnerability a lot of publicity. There's one other thing we want to make sure that we talk about, and Lou, I want to talk about this with you, because these systems use Apache Tomcat, and there are reports that these systems that were developed may not have kept up with all the Tomcat vulnerability patches and updates that could lead to vulnerabilities in the fully developed systems. Now, you work managing developers. When you're looking at systems that use a lot of other components that were developed by other people, what kind of practices are in place? I mean, is it a best practice to fully vet and patch all of the components that you're using, or do you tend to rely on the reputation of the people developing those other components and use that as a way to save time in your development process?
Yeah, that's a really good question. Actually, there's a fine line between, hey, let's use some open source to get ahead in the game, to not have to write something into share code, versus introducing something that might cause a vulnerability or not be just right for us. And there's a lot of times when you use open source libraries or application code from other teams, and you're going to have to do your own due diligence on that code to ensure that you don't have these issues. There's a lot of times we'll pull stuff in and we'll run it through the gamut of testing. We have what we call horizontals, where we say, hey, we do a set of security testing and performance testing and memory leak and resources and all this stuff to ensure that it's up to par with what we want. And then we also look at, anytime a new library comes out, let's say you're using open source 1.1 and 1.2 comes out, we always look at the code and what's different, what's changed. We run it through the gamut as well. We make a really conscious decision whether if it's a security patch they're fixing, whether we should take it or not, and how fast we should get it out. So there's just a lot of things to think about. And when organizations are having to think about that stuff, they tend to forget some of the kind of the areas and the avenues there. So and the perfect example is forgetting to patch things because they don't want to potentially cause compatibility issues with their devices or their servers or so on. So they tend to kind of only roll patches out every so often. We have lots of times problems here, even internally, where we have compatibility with some of the newer stuff, which is why we do automation on all of our software. We say, hey, if we're using, let's say, Outlook on a machine and we want to make sure it works on the newest version of Windows, we always have an automation machine running Outlook on the newest version or the latest version of the previous versions to make sure that compatibility works. And a lot of these organizations have to start doing that to kind of cut their costs down when they get hacked because they're not up on the patches. So I think more organizations have to start doing that.
Let's see how I did for 2017. My short term was that machine learning changes network security and application configurations because human beings are just too slow. Now, I'm going to say yes on this because things like intent-based networking and software-defined networking are changing configuration and security all up and down, whether you're talking about local area networks, enterprise networks, or the big carriers. We're having machine learning and artificial intelligence taking the place of human configurators in many cases. So I feel good about that one. My medium term was that voice becomes the way most users do most of their computing. Still, I think a wait and see on that because, well, as we said at CES, we saw lots of devices, especially automobiles, being added to the ecosystems, but we're still moving in that direction. We're not there yet, and there's always a chance that something will come along and change the way that happens before we get there. And finally, the open internet is over. Now, this didn't really have as much to do with net neutrality as it did with the fact that there are a lot of governments that just don't like open internet. They want to have control over what is said and basically what their citizens can read. Now, we're seeing this in a lot of different directions. In some totalitarian nations, they want to keep their citizens from seeing what's going on outside or keep them from seeing groups that criticize the government. In other places like France and Germany especially, we're seeing efforts to clamp down on fake news. One way or the other, there's the sense in government institutions that the internet is just too open and that, frankly, as citizens, we can't handle the open. So I still think that is largely going to be true, and I don't know that I'm completely happy about it. Lou, I want to toss to you first. What do you think about my predictions? How did I do?
So for the machine learning from the security perspective, I think you hit that one right on the head. I think there's so many different adoptions of the fact that, you know, companies and security firms, they can't do this all by hand, especially with monitoring tools. They have to have the ability to bring in different facets and different vectors of data. In order to analyze that, they're going to need some kind of horsepower and computation power, and that's kind of where machine learning brings in that capability to devise models. And they're ever changing and adopting and evolving models, but they are models to produce that information. And I think we're going to see that more and more. And we did see a ton last year. There was a bunch of pop-up applications and companies that have kind of devised new systems for that. We even had a couple of them here on TWiET. So I definitely think that's a yes. Voice being an input. This is an interesting one because, you know, a lot of companies, especially coming out with new PCs or new devices, you think that they'd add the voice capability. Yes, they've definitely added Alexa and other applications, other assistants into their devices. And so you'll see a lot of new IoT, you know, whether it's a light switch to a light bulb to a smoke detector. They all have kind of like Alexa built in. But has it become like the most used input for computing? I say no, but it's on an up and up. And is it trending? Absolutely. I think it's definitely a way, like you said, you saw automobiles and, you know, a lot of IoT devices and other things kind of adopting. So I think it's on its up and up. It's trending, but it hasn't hit that critical mass just yet. And then the open internet, I'd say, I don't think it's gone yet. I think we still have it. I think there's still that residual effect of the demise of net neutrality. I think that the residual effect is companies are being real careful about what they do because they don't want to be pointed as the liar of the group. People who they've said, hey, we believe in net neutrality, and then they kind of deleted that from their sites, and now they don't want to be known as the company that took the back step. So you haven't seen anything yet. They're waiting for that to die down before they take their action and pounce. And I think that we'll probably see that in 2018 potentially from some corporations because they have to redo their fiscal year goals, and so they're going to have to find new ways to get more money. And I think that we'll see some companies doing it, but I think at this point, I don't think it's gone yet.
All right. You know what? So a mixed bag. Brian, what do you think?
Okay, so short term machine learning, big yes, right, nail on the head. I think we're going to actually see a lot more. I think we're going to see that segment speed up. Now, voice becomes the way most users do their computing. I think that's slow. I think we've got a lot of intent, But I think one of the things we're going to need to start doing is more local computing power, because having to depend on sending it off to the internet means you're going to have an always-on internet connection. And yeah, it's there, but not really. And so I'm saying that's a slow. And as far as the open internet, I don't think the game's over in the United States. The game is very different in some of the other countries. We're starting to see a lot more governments making requirements, and China's definitely one. You know, I have a researcher in Beijing right now, and he cannot use Google at all, and his VPNs don't work. And so we're going to start seeing that in other countries, but I don't think the game's over in the United States yet. We need to move on.
Brian, we're going to let you take the first crack at telling us what's going to happen.
Well, I think in the short term, because I'm already starting to see it right now, going beyond hybrid clouds into augmented clouds, where new services like smart load balancing, IDS, IPS become much more common for cloud providers to link on-premise to the cloud. I think in the medium term, we're going to see more work in natural language and voice interfaces. I'm a firm believer in this. We're starting to finally appear in networks, enterprise network solutions. We already saw it with Tim Titus in past solutions. I'm thinking I'm going to start seeing this in things like Salesforce and SAP, and Google and Amazon are going to race to see who's going to rule the voice enterprise world. And my long term, and I'm saying this is long term only because I just got a memo from Verizon and another one from T-Mobile about how we're supposed to start from the machine-to-machine world, phasing out our 3G modems because we need to make room. That spectrum is going to be given over to 5G. So I'm saying in the long term, 5G mobile services are going to be announced towards the end of the year, and they're going to start warning people to phase out their 3G in the 2 to 3 year time span. We're going to start seeing a whole bunch of people doing trade-in deals and things like that because we're going to need to make space.
You may remember that last week the Trump administration floated the idea of a nationalized 5G network. Now, it was immediately attacked by the telcos, by the ISPs, and even by FCC Chairman Ajit Pai. Now, the admin has since walked back the language, trying to explain it as just one floated idea of many, but we thought that this might be a good time to take a look at what a comprehensive, intelligently planned nationwide 5G network could actually do for some of the underserved parts of the United States. Now, I want to start this discussion with a big caveat here, and Lou and Curtis, I want to get you in on this. I will say unequivocally that wireless, no matter how fast or ubiquitous, is not a replacement for fiber. Would either of you agree or care to take issue with that statement?
I agree. I think, because of the environment and all the single attenuation, all this stuff, that, wireless is always going to be susceptible to the environment and other things. And with fiber, it's you're able more controlled environment. So I agree with that.
Right.
I think it's highly application dependent. If you're doing business work, if you are pushing video, then absolutely fiber is the way to go. But I think for the vast majority of consumers, 5G could be a very worthwhile replacement for fiber, just because the fact is that most consumers will never need or really use the full bandwidth of fiber to begin with.
Right. And I see that from the point of an end user. However, my point is, at some point you tie it to ground. At some point it has to tie into the network. So it doesn't matter how advanced your wireless technology is. If it doesn't tie into a fiber network at some point, it doesn't tie into everything. It just doesn't work. So, I mean, it's one of these things where if you think in terms of fiber deployment as your backbone, and you know that you need to get fiber out there eventually, but you use a fast wireless technology as a stopgap, at least as a way to get that last mile or a way to serve areas that are very problematic to get fiber out to, then I think that still makes the statement true. But let's go ahead and jump into the story, because even with my love for wireless, for wired, I think wireless does offer huge advantages to rural and underserved areas of the country. Let's look at 4 things specifically. 1, it's cheaper. Now, the Wireless ISP Association estimated that a wireless connection to a rural endpoint could cost as little as 1/10 as much as wiring the same location. Now, Curtis, why is that? What are the costs associated with getting fiber out to a place that might be 2-3 kilometers from a POP?
Well, almost all of the costs are because of the physical nature of fiber. You have to do one of 2 things. You either have to string it on a pole, or you have to bury it, or more likely some combination of the 2. And let's remember that with a lot of the places that we're talking about here, once you get to the customer's mailbox, you may still have a quarter mile or more to go before you actually get to their house. So it's a non-trivial cost, and the population density is such that it's difficult to really distribute that cost over a huge number of customers. And there are some very fixed costs. I mean, if you have to roll a ditch witch and its crew and put all of the stuff in the ground to safely hold fiber, that cost is fixed, whether you're talking about serving 1 customer or 10,000 customers. And it's the fact that we're talking in most parts of the country closer to 1 than 10,000 that really makes this cost prohibitive.
Precisely. And I think you picked up on the main reason why Verizon and the other large incumbents don't like to do rural. It's because a kilometer of fiber can serve either 1,000 customers or it can serve 1. Which would you rather have? Of course, you're going to want the areas that have a lot of customers because that's more profit. However, their charter is to serve even the one that does 1 customer. Now, this also ties into the second point, which is it's ready for deployment. Lou, I want to throw this over to you. This has been something that we've covered on TWiET a lot over the last couple of years, and that is it's complicated. When you want to deploy someplace, it's not as simple as renting a ditch witch, digging up the street, and throwing down some conduit. There's a lot that goes into that actual planning and then deployment. So when they say that wireless is ready for deployment, what are they actually talking about? What's the difference between wireless being ready to deploy and fiber being ready to deploy?
Well, there's 2 parts. There's obviously the carrier, and there's the device that's actually giving the signal off, and the device that's accepting it. And when you don't have devices even available today that are supporting this spectrum and the new technology, and then you really don't have a full deployment yet, even though if you might be available on the towers that are being. Also, with 5G being at the high level of the spectrum, much higher frequency, you have to plan out and determine how to do that overlapping coverage. And in order to have a full deployment, having overlapping coverage, especially in an area, you have to make sure you plan that out. And most likely, because 4G is a different technology, you're not necessarily done with it yet. And so they need to basically ensure that the coverage is going to be available to call out a full deployment there. So I think there's a couple parts there that needs to be called out.
Right. Curtis, I like this next part because this dovetails with a lot of the things that you said about when a technology is available and when it becomes, well, actually useful. And that is that wireless 5G, especially in these rural areas, can actually be more reliable. It can be more dependable than fiber. I know that sounds counterintuitive, but existing urban developments have shown that maintenance of rural lines can actually be more of a time and resource sink than the deployment. There's always something going wrong. There's always lines going down, and it becomes very difficult for ISPs to respond to those problems that are so far away from all of their regular concerns. How is it that something like 5G might be more reliable than having a fiber run dropping down into the middle of your community?
Well, once again, we're looking at density issues. They can put a 5G tower up to serve a large number of customers. And therefore, if there's a problem, they have a lot of incentive and a lot of economic incentive to get that tower up and running. Plus, because of regulations that are in place, every cell tower, if it carries voice, it has to have a certain number of hours of battery backup. Many of them also have generator backup. So there is deep redundancy built into a cell tower. That redundancy is not built into every kilometer of fiber that is strung along a country road. And once you get out of the cities, there is lots and lots of this country that from a fiber run standpoint is pretty hostile territory. I mean, just look at the weather forecast for the weekend. We've got a big winter storm moving across the northern tier of states. That's going to carry with it in many places ice. Ice brings down fiber and copper and everything else. So it's fragile. The radio waves just don't have to deal with that. And the frequencies that are being used are pretty resistant to weather-related interference. So from the point of view of a consumer-level bandwidth requirement, 5G is just a much more resistant, much less brittle medium than is anything that can be described as cable or fiber.
Yeah, and I know, again, that's counterintuitive, and we've all been trained, and we've all had experience of wired/fiber being more reliable than wireless, but again, rural areas play by slightly different rules. Oh, the fourth one, and again, this is one of those kind of counterintuitive things, is that it can actually be faster than typical wired to these locations. You have to remember that with the distances that we're talking about, you're always going to get a loss of signal, be it copper or fiber, and you're going to need a lot of equipment to repeat that signal. Well, with the current state of 5G, and remember, we don't have a standard. We don't have a technology that we can say is 5G, but we're looking at a combination of technologies. Millimeter wave radios, something up in the 600 megahertz range and 600 hertz range, UHF radio. A combination of these is what we're actually looking at when we do 5G deployment. Right now, they're saying with the technology that we have, you're looking at a minimum of 50 megabits per second. And with the gear that they're looking at and the standards that they might include in the 5G standard, you could be up to 200 megabits per second non-line of sight, which is amazing. That's, if they could actually make that work, that would be fantastic. Make it work outside of the lab. So let's go ahead and take those. Those are the four reasons why we might want to consider a 5G network, especially in rural areas. Right now, the FCC is estimating that there are 20 million Americans living in rural areas that don't get any sort of broadband service at all. So we can look at this and say, this could be a way for us to get out to that. These people, these communities have been waiting for decades, for literally decades, watching the broadband revolution pass them by. And they're starting to realize that this is not just email and surfing, that there's an entire part of the economy that they could be participating in if they just had broadband. Curtis, I want to throw this over to you, though. 20 million Americans looking at a broadband deployment of 5G across the nation that's going to cost billions of dollars. There's going to be people who do the cost analysis on this and say, maybe the incumbents have it right. Maybe we don't deploy to rural areas. What's the response to that?
Well, you can see that, and I think what we have here are the limits of pure capitalism, and it becomes a very philosophical thing. The pure capitalist, pure free market fans would say that we let the market, let the incumbents figure it out, while others point at the potential advantages to the broader economy and to these 20 million citizens. And say that it's worth some sort of societal investment in them, whether that investment is made through the government or through the higher tariffs all of us will pay if the incumbent wireless providers are required by regulation to provide this. Personally, I think that there is a compelling case to be made for doing some sort of nationwide 5G coverage. I'm much less entrenched about the mechanism that's used for that. But I think that pretty much blanket coverage of the nation by 5G has a lot of good things going for it. And I would be in favor of it, recognizing that because I live in a place that's already served by broadband, I would end up paying for it. Hey, it's what neighbors do. But I think that there is a lot of business to be unlocked out there. I have covered a lot of agriculture, for example, and it's astounding what the agricultural users, the agriculture industry is doing with its current level of bandwidth, food production will become safer, and the facilities will become more productive with better broadband. And I think that's the kind of thing that makes it an advantage for everyone.
Yeah, it's we've got a very good conversation going on in our chat right now between Chumley, CR1, Y Guy, and Emily the Strange, talking about exactly this idea of there's a couple of different ways you can look at this. Like you, Curtis, I fall into this category of you could actually advance these areas quite a bit. There's a lot you can do with a broadband connection on a farm. I know it sounds weird. I know it sounds like that's not a good matchup. But it's amazing to look at what some of these technologies can actually do for the production on farms. The other part, and Lou, I'd love to get your input on this, is what we do. This was the promise. This is not an add-on. When we started giving right-of-way to these companies that have deployed networks across this country, this was part of the agreement. This is, if you remember, we used to have the rural telephone fee, and that was to say, look, the cities are going to subsidize the deployment of networks out into these rural areas, which the telcos never really did. So we kind of let them off the hook on that for the last couple of decades. But that doesn't mean that we're not still supposed to do it. We're not arguing whether or not these communities should be served. We're arguing how they should be served. And now we have a technology that can do it much more quickly and much faster than with technologies in the past. So, Lou, for you, I mean, how do we sell that to the people? You know, having in the back of our mind that we shouldn't really have to sell this to the people.
That's a hard question. I think that, you know, the telcos, if they're kind of forced to do what they're supposed to be doing, they're going to go back and do whatever's cheapest. And so in order for them to serve the public correctly and be able to bring forth all the advantages of some of the newer networks, you know, the people are going to have to step in and start and voicing their opinions and get their representatives to represent them correctly. And I think, you know, again, because the rural environments don't have this technology today, they tend to not know what they're missing. And so kind of pushing the envelope there is going to be really difficult, you know, without a campaign to bring those people forthright. And so I think that that's what's going to be the main problem is somebody's going to have to take that responsibility to bring the people along with them. As well as you know, market this capability to have the telecompanies actually come forward and do the work. Otherwise, if they're forced to do it, they're just going to go back and say, you know what, we'll just implement, you know, 2G or 3G in some areas to get people on board, and then we'll fulfill our promise. So,
all right, I want to throw one last bit out, and either of you can answer this. There is a concern here that, in order to entice the telcos to do this, we have to do something that even this show has been very against, and that is allowing the telcos to get out of their responsibilities, their previously established responsibilities, to deploy to urban areas if they're willing to make the investment into wireless infrastructure. Is that a compromise that we have to make? I mean, I think that's why the nationalization discussion came up, which is let's still hold the telcos to their agreement to deploy to rural areas eventually, but we'll use a nationalized network in order to get to them now. What's the right tact here? What's the right strategy? How do we make sure the telcos do what they said they were going to do and at the same time get service to these people in some sort of timely fashion? Anybody?
Well, I'll leap into this particular pit of twisty, turny arguments because I think that the real issue is that we're talking about encouraging the wireless companies to do something on a national basis, when in many cases the actual implementation regulations, requirements, and all that happen at a state level. So one of the great things to be decided is whether this becomes a truly national issue or it remains at the state. Again, I think there's a compelling case to be made for doing something on the national level, just because we do regulate the spectrum at a national level. And so the effective way to do it is somehow tying it to spectrum licensing and allocation. The problem is that we have an FCC that has just swept away network neutrality rules. It's very difficult for me to foresee a scenario in which they would decide that they're going to throw this level of regulation onto the wireless carriers, which leaves market forces. And, well, we see how well that's working so far. I'm not sure what we do to get market forces to work better.
SpaceX just got the FCC approval to blast off into the WISP market. That's right. They're going to become a wireless ISP. Now, the FCC took a look yesterday at SpaceX's plan to provide global satellite broadband services. Of course, this is going to be with a series of low Earth orbiting satellites, and they see nothing wrong with the plan. Quote, this is the first approval of a U.S. licensed satellite constellation to provide broadband services using a new generation of LEO orbit satellites. And the FCC also said, with this action, the Commission takes another step to increase high-speed broadband availability and competition in the United States, unquote. This has been a plan of several companies for quite a while. Boeing has been trying to get into the game. You may remember the Iridium system, which is still currently up there. But this is Elon Musk's SpaceX saying, no, we think we can do it better. We think we can do it faster. We think we can do it cheaper, and we think we can cover more of the planet with newer technologies. That's got me incredibly interested. Now, the plan calls for a constellation of, get this, 4,425 microsatellites in low Earth orbit. Now, they want to provide low-latency broadband specifically to rural and remote places with little or no internet access, and then also improve speeds and competition in areas with so-so access. Now, they are operating under the code name of Starlink. Who knows if that's actually going to work? I was thinking Space Tesla would probably be better. They've already got a car up there. This is a fascinating project, and if you dig down deep into the actual tech specs, you can see why this is not like previous generations of LEO satellite constellations. They've got a lot of self-healing. They've got a lot of very fast processing, and they've also got some tricks that they've learned with using corrective, not convenient, but very constructive use of distortion, atmospheric distortion, to correct for latency issues. Cheever, let me throw this over to you first. They're saying that this might be operational mid-2020. SpaceX has actually been pretty good about deadlines. Do you think this actually could be? Could they get more than 4,000 satellites up by 2020 and have them operational?
Well, you got to keep in mind, these guys are talking about really small satellites. And considering that heavy lift, the Falcon heavy lift, that could, one Falcon heavy lift, my best thumb guess swag, I would say Falcon can probably drop in a couple hundred of those microsatellites, don't you think?
Yeah, and actually there's a great graphic of, I'm not sure if SpaceX did it, but they showed the deployment of microsats and how it would just open up the cowling, and then they're basically ejected, like spring ejected, out into their proper orbits. It is a fast. I mean, I love space. Space was my first love, so this really makes me geek out.
Here's the other thing. SpaceX has been a very big player in the world of swarm control satellites.
Right.
And when you start having a swarm control over satellites, to be able to shift things around, antenna orientations and things like that, I think we are not far from being able to literally have the Star Trek communicator badge in the middle of the Sahara Desert calling home to say, hi, Mom. What do you think, man?
Yeah. Well, I mean, for me, it's all about the bandwidth. Curtis, let me pull you in on this, because I've used satellite systems before, and they always have the advertised speed, 4,800 bits per second. Realistically, I was getting something closer to 2,400 bits per second, and I don't think 9,600 bits per second is even possible over a satellite connection currently using what we've got up there. This is supposed to rival wired connectivity to your home. And when I first saw that, I thought, that's ridiculous. That's not going to be possible. But then, again, you read down into the tech, and it does look like they can actually meet some of those goals. If they could provide ubiquitous connectivity at a price that was comparable to a wired connection to your home, this isn't just another service provider. This is a complete change to how we think of broadband.
Oh, it's got to be one of those things that just irritates the daylights out of all of the cell-based ISPs out there, because this allows the possibility of having uninterrupted data coverage. Right now, even with the best of the data providers, once you get out into the boonies, there are big holes in the coverage. You really cannot go coast to coast and have solid wireless data unless perhaps you stay on a couple of the major interstate highways. So if you start looking at what they're doing, imagine they've got all of these up and they have the ability to talk to their automobiles coast to coast. They have the ability to update the Tesla automobiles wirelessly coast to coast. Plus, they can begin to do things, I have to imagine, like doing very, very high accuracy location off of these. Right now, if you think about it, if you let a little settle happen and you can see 7 GPS satellites, you can get very good location. Imagine if you were doing time-based location and you could see 100 satellites. I can imagine getting down to something that approaches millimeter accuracy from a satellite-based location sensor. This is a game changer for a lot of different industries.
Right. Well, Eric Duckman is wondering if this is more of a medium orbit system, but definitely not. Compare this. When you think of satellite, you can think of something like the HughesNet, which is a satellite internet service. They're orbiting at about 22,000 miles. This is going to be closer to 700 miles. So this is not just low Earth orbit. This is very low Earth orbit. And that's why they can get the latencies so far down. One of the other things about this is they are looking at distributing over the United States first. So they need about 800 satellites. If they can get 800 up, that will cover the continental United States, and that becomes your test bed system. Then you go out from there. You just expand the constellation. There is a question on how often you will have to replenish the satellites in the constellation, because the lower you get into orbit, the more drag you catch, which means you either need to refuel your satellites so that they can boost themselves back up to the proper orbit, or you just expect them to die and you need to be replacing them on a regular basis. Those things still have to be worked out. This is just proof of concept. But again, this sounds like, yeah, Cheebert, like you're saying, this sounds like Star Trek communicator stuff. Being connected anywhere, I have clear view to the sky.
Well, let's put it this way. Global Star, which is actually a reseller for Iridium, has sub-channels. They're basically at the very fringe edge of the Iridium data channels. And they, just by offering, they now have a $65 a month plan where I can send an unlimited number of 240 character text messages both inbound and outbound. Now, the cool thing is this will work everywhere except the poles. And with that kind of coverage, I can fit, if I do some data encoding, I can fit an awful lot of data into 240 characters. Now, if we start getting it into super low Earth orbit, because Iridium's fair, it's low Earth orbit, but it's at the high end of that band. If I only have to punch through about 700 miles of atmosphere and weather and so forth, now we're starting to talk about, instead of having a modem that's maybe about that big, if you can, like a deck of cards, that's how big my Global Star modem is for the Raspberry Pi. I am going to imagine a reasonably robust modem for Starlink is probably going to be about the size of a golf ball with batteries. Now, when you start getting that small, now all of a sudden we can have temperature and intrusion sensors on refrigerated containers. We could probably get it cheap enough that we could track high priority packages. as they go across country. I'll bet you Amazon's going to be a customer because they're really big on having packages delivered on time to the point where they are starting to pay penalties in some cases if they don't make it. It's to the point where UPS drivers will sometimes mark a package as delivered even though they didn't deliver it because there's so much pressure on this. So tracking food, tracking high priority packages, and being able to do it internationally is a pretty big deal.
Right.
To the point where the federal government was getting ready to hand me a lot of money for food safety tracking, just so we can keep track, make sure that that gallon of ice cream never really defrosted.
Another tidbit about this, because I Am Special asked about, he thought he heard lasers in reference to the story. Yes, actually, one of the proposals is that the satellites would use lasers to communicate with each other. So that's super low latency communication between the satellites, but then they would still use the KU band to do terrestrial communications, because shooting a laser through 700 miles of vacuum and atmosphere, it's not going to work out so well. And actually, Curtis, you're a ham, right? I mean, KU is the most efficient way to get into space.
Oh, it's a very good way to get into space, and let's remember that we are in fact talking line of sight, and it's possible to do line of sight communications with very low power. I've talked to the ISS using a handy talkie, so this is not a serious technological trick at all when you're talking about the RF bands that they're using. Chibert talked about, he mentioned a word that I think is going to be important when this goes to full rollout, and that's international. It's one thing to say that they're going to provide this for the United States, but let's remember that there are an awful lot of countries out there that have internet kill switches on the gateway routers for their nations. There are any number of countries that have the capability to shut down access to the global internet from their nation in the event of unrest or attack, or because they just want to. Padre, you mentioned at the very beginning of the show, or when we were getting ready, the idea that when you go to China, it's tough getting a VPN to work because of that nation's control over its routers. But if you don't go through their routers, if the access of your citizens to the internet or of visiting citizens to the internet isn't dependent upon what happens through your national routers, that has the potential to be exceptionally disruptive on a geopolitical basis. And knowing Elon Musk, he's thought about that a lot.
Right. Well, I mean, think about it. You might be walking around with your cell phone. You might have a Wi-Fi connection at home. Maybe you even have a hotspot that uses a different provider, but they're still all using terrestrial-based networks that can be shut down. If you're using a space-based network, unless the country is willing to blot out the skies with KU interference, you can't stop it. You can't stop me from getting to a network that's not under your control. That appeals to the sort of semi-anarchist side that I might have on the dark side of my personality.
Hey, Padre.
Yeah.
Maybe that's why there's so much pollution in Beijing. They're blotting out the sky.
Blotting out the KU band. Maybe so. Now, actually, one of the other things that's been mentioned in the chat room is about how difficult it was to set up satellite radios. And Chibert, I don't know if you ever used one back in the day. I used to have a set that you had to set up, and then you actually had to look at the tables to find out where the satellite might be at the time, and you'd have to aim it exactly until you started getting signal from that satellite, and then it would have to track it, which was
I had a briefcase in Marsat phone.
That was horrible. It was cool, but it was horrible because it was difficult to get the connection, and it was almost impossible to maintain the connection for a period of time.
It was bad to the point where we actually had a HP programmable calculator in the suitcase, so we could punch in our longitude, latitude, and time of day at GMT just so we knew where to point the stupid thing.
Yeah. Well, today's sets, because we've made great advances in RF design, they use a flat panel, and they basically just steer the beam. So it's pointed at the sky, and you'll find a satellite. And if you've got a constellation of satellites, it can even do better than that. It'll look for the satellite with the lowest latency, which this is kind of amazing technology. I mean, I want to see it work. I want to see a prototype. I want to see what kind of pricing they might have. But if they can deliver this, this is not just an IT development. This is a worldwide communication / global awareness development. And I think that's kind of awesome.
Yeah, well, I carry a Global Star modem with me when I travel. I put it into emergency mode, which is basically 20 messages in and out. But that only cost me $12 a month, and I just carry that as my emergency. In fact, I'm going to go to a wedding in Vermont in October, and considering my experience with some of the areas of Vermont where there's nothing, I want to have the ability to go and be able to call for help.
Right.
Call me paranoid. And something like this Starlink system would mean that would be a lot less expensive, a lot more ubiquitous, and possibly even better coverage, which would be amazing if you ask me.
So you remember those 500 million accounts that were stolen from Yahoo last year? Well, it's thanks to people like Cameron Baratov. So don't think this is his first rodeo either, though. Baratov would go and register domains, whether I think he has 81 to his name. Some are just email provider references, such as accounts, google.net or yandex.com. And also he has just plain old email hacking services like infotechteam.com. And he would market them as quality mail hacking to order without changing the password. And the service basically charged $60 per password. He even had antimail.org, which is another domain. And he basically advertised quality mail hacking to order. Well, how was he doing it? Was it some magic hardwired into some chip? Well, nope. Baratov would rely on spear phishing emails that he would target individuals by using personalized information. He would have links to sites that had fake or but familiar login pages. Users might actually type in their username and password, but they also let the attacker do is steal their cookies, which are sometimes little hidden files that are given by sites and stored on your machine. And sometimes they store whether you've been authenticated with a site or not before. So according to his other sites, he also had xssmail.com, and he used techniques as XSS or cross-site scripting, which would rely on vulnerabilities of the website to not properly parse the data submitted by visitors, as well as, along with XSS, he also had cookie stealing exploits, which these could be collected by another accuser. And that particular accuser is another Russian national called Alexei Belin, and he would actually use those cookies by that person. In the Yahoo case, though, once an employee was phished, the hackers got in and they unlocked all the other accounts. So what was Karam's charges here for doing all this? Well, he had 47 criminal charges that included conspiracy, computer fraud, economic espionage, theft of trade secrets, and aggravated identity theft. Karam did agree to the plea agreement, though. He admitted he hacked at least 80 webmail accounts on behalf of the FSB, which is the Federal Security Service of Russian Federation, which is essentially Russia's version of FBI. He also admitted to 11,000 webmail accounts since 2010. So what happened to that assisting Yahoo accounts stolen, those 500 million Yahoo accounts? Well, what did he get for all this? This past week, he was sentenced to 5 years in prison and $2.2 million fine, which is $250,000 for each account. What did the Justice Department seek? 8 years. 8 years. That's it. Plus, they can't even seize his assets in Canada since he's a 23-year-old kid. He actually made his first $1 million at the age of 15. Okay, so there's many different, numerous angles we could talk about here, but I first want to start with the phishing part. So, Curtis, I remember reading in multiple of your articles about phishing and how even social media now is one of the highest attack services rather than email. Is this just an ongoing effort? There's just going to be more and more pop-up ways of phishing information for people?
Oh, absolutely. As you say, social media, I won't say that it has passed email phishing yet, but it is certainly growing very rapidly, and a number of experts feel that it is the more serious challenge at this point. In addition, we're hearing terms like smishing used. That's phishing activity using SMS messages, and whishing, which is phishing activity using WhatsApp. So the bad guys are turning to all kinds of communication channels in order to try and get people to give up personally identifiable information. The big reason for that is that in general, the education efforts around email phishing have been at least reasonably successful. So, pardon me, you really have to send out lots and lots of email messages or spend time to develop a truly compelling spear phishing campaign in order to make email a viable channel. It's just going to keep growing, though, because regardless of how it leaves the organization or leaves the individual, that personal information is a very valuable commodity.
Right. Now, we had a guest back a while back, Ray Pompon from F5. He had talked about phishing and how he actually pointed out that it's really hard to fully educate people, since the bad guys are essentially con men and they just use psychological warfare against people. And so I don't know if there's really an easy way to do this. In fact, I remember even seeing phishing USBs where people would just leave USBs in some kind of random place. People would take them, pick them up, and use them because they were quote unquote free. So I think the question here is, Padre, what how can we protect ourselves here? Like what can we possibly do in this day and age?
We can't. Okay, no, let me continue though. But that really is an honest answer. This is just like the conversation we had at the start of TWiET, because if you remember 6 years ago, we were really starting to make that transformation from perimeter security to a more holistic model of security. In other words, you just have to assume that the attackers are going to get inside the walls. This and all the current attempts to stop phishing are perimeter security. We're saying, okay, we're going to stop people from getting phished. We're going to stop people from falling for these scams. That will never happen. You will never be able to do that because of human nature. Some of us are just going to fall for scams. Some of them are really good scams. Some of them are convincing scams. I mean, this is what these people do professionally. So the only real response is to make that same sort of transformation. You have to move from this perimeter security view of securing your users to just assuming that at some point your users are going to give up credentials, your users are going to get hacked, they are going to get owned, their devices are going to get compromised, and you need to be able to have a security model that can survive that. Until we do that, this is all just theater. Because I remember the interview we did with F5, where we discussed much of the same thing. And at that point, we were talking about the USB sticks that people were leaving on the ground. And then someone would say, oh, hey, free USB drive. They'd plug it in, and now their computer is owned. That sort of attack will never disappear. So what are you doing for your employees to, A, educate them so that they're less susceptible to fall for these scams, and then, B, assuming that they will fall for the scams, to make sure that their access to information has graded levels of security so that even if they surrender one set of credentials, it's not giving away the whole farm.
Right. Those are good suggestions. Hey, Curtis, is there anything else we can do here?
Well, just wanted to add to what Padre said, because we teach people to do things like hover their mouse over a URL to see if it really goes to the display string, things like that. But the bad guys are ever more sophisticated, because I've seen many more Unicode attacks lately. We're used to the characters being encoded in ASCII, so that there's a specific numerical value for each code. Well, you can use Unicode and display something that has very little to do with the ASCII representation. So you can hover, it will show up being just right. When you click on it, it goes to someplace on the dark web. As Padre said, we're never going to eliminate this. That's why what we really need is a combination of education, procedure, policy, and technology that gives us the layers required to at least knock our organization off the list of low-hanging fruit for these criminals.
Right. So let me address the elephant in the room here, because this is kind of the strange part of this. And so this particular hacker was only sentenced, with all the things that he did, he was only sentenced for 5 years. That's it. And a $2.5 million fine, which he has money up the wazoo hidden somewhere that he can pay with. So 5 years is really nothing for a 23-year-old. Padre, is this the right message we're trying to send to hackers? Like, you steal 500 million passwords and expose 500 million people, you just get 5 years.
Yeah, and we can go back and forth on this. I'm just going to speak for myself. I'm speaking from my own personal opinion on how you do this sort of sentencing. You have to set the sentencing to encourage the behavior that you want. And set aside all the politics here and what happened. What we actually want out of people like this who do have skills is we want them to be good citizens of the internet. We want them to use their skills productively, beneficially for everybody else. So a fine and some jail time that is probably going to get commuted down, 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 and down is really not going to do what you want it to do. The way that you hurt people like this is you take away their access to the thing that they love the most. You give them an incredible sentence, a ridiculous sentence, a 40-year sentence, and you suspend it and say, you can't use a computer. You cannot be connected to a network for the next 10 years. That's basically a life sentence for a person like this. It takes them away from their livelihood. It takes them away from the thing that they love. That's actually going to be far more of a detriment, of a deterrence to people who might do this sort of behavior than saying, yeah, I'm going to fine you some arbitrary amount, which you probably already have stashed away, and I'm going to give you a prison sentence that I know you're not going to really serve. So that's just me. And when you see me at DEF CON in August and you don't agree with me, feel free to come on up. We'll have a beer and discuss it.
Absolutely. Yeah. I think it seems like to me this guy's laughing as he kind of walks into prison here. He's getting a slap on the wrist. Curtis, what do you think? What's the best course of action here? Do we need to send the right message somewhere?
Well, I think we absolutely do need to send the right message. I'm with Padre. I'm not sure that this does it, but I also am not sure that our current laws really have a mechanism that works against criminals like this. I think it's worth pointing out that he was one of 4 people indicted. He's the only one of the 4 who will ever do any time, because the other 3 are Russian nationals living in Russia, and 2 of them are agents of the FSB. So we know that nothing is going to happen to them. So what we have are 4 indicted individuals. 1 cops a guilty plea, and for the entire episode in which over 1 billion records were compromised, we have this result. I don't think this really discourages much of anyone, especially when there are the amounts of money floating around. And I've got to say, in reading about this pre-sentencing hearing, I got to love his attorney, who basically said his defense is that he was just doing so darn much hacking. Someone who hacks as much as he does really couldn't have known that this was the Russian government asking him to do it. So he's less culpable because he did more and worse things. I love the world of the legal argument.
Absolutely. So what about Yahoo here? Like, I think we've talked about this a little bit in the past, but Yahoo is really not really being held accountable other than maybe their stock drop here. I think, is that really enough? Like, should companies like Yahoo or whoever these other companies, we talked about breaches in the past that have leaked this information, obviously people can bring civil cases against them, right? Padre, I think, is that enough to kind of send the right message here? I don't think it is. It's
not, but we do have an example right now of something that may be enough, and that's the GDPR. So over in the EU, they have fully implemented, well, supposedly, the GDPR regulations, which will allow them to fine companies who do not properly protect their customers' data up to 4% of their net. That's not a slap on the hand. That is a full-on salvo in the face. Now, of course, that's just in the EU, and we are still trying to figure out all the ways that this is going to go wrong. We know there's going to be a lot of things we have to tweak. But what I love about this is that in 3-4 years, the United States can look at what happens with GDPR and say, okay, this is what worked, this is what didn't work, this is what we're going to implement. Bold step by the EU, and I think a necessary step. All of their missteps are going to help us, the entire networked community, in the long run.
Now, we only have to do these now and then, but we have a new survey for you. Now, since our listeners are techies, this one focuses on your collaborative software at work. Now, the survey is brief, takes about 6 minutes, and it does not collect any personal data. The URL is twit.to/survey12. That's twit.to/survey12. And we thank you for your support. Tim, you're in studio for our 300 episode. Welcome back.
Yeah, thank you. I was here for 200, and it was a lot of fun. I figured I got invited back for 300. I think you guys only invite me because I bring cake. Isn't that the reason?
No, I don't think so. I think it's just because you're the network geek of geeks. I think that's why we keep bringing you back.
Welcome. I'm an old hat network geek. I'm hiding the gray hair.
It's a layered thing. It's a layered thing. Yeah. Fantastic. Well, welcome back. We have a great bunch of great topics to talk about today. Of course, the third 300 episode, and of course, one being network automation. And of course, some of the topics that we're going to talk about today, what you'll notice is there's some points that kind of go in the same direction. One being that there's more and more devices, more and more people on the earth, and it creates for more and more complexity in our networks, and we have to find ways to kind of cut through that complexity. Now, some of the topics today are talking about a little bit about Cisco DNA and Cisco ACI. Can you just give me the folks at home, a little bit of summary of what those are and what they kind of help you do, what kind of organizations help they do?
So Cisco DNA, so I was out at Cisco Live just, I feels like a couple of weeks ago, but I think it was actually a month ago. And fantastic show. Big thing that was really being talked about a lot was Cisco Dna Center. And for folks that don't know what Dna Center is, it's actually a really cool piece of technology that I figure it's definitely one of those pieces of tech that's going to have some legs. What it allows you to do is to dynamically change the configuration and operation of your network either at a push of a button, or you can schedule to have your network changed. Now, what this really means from a business side is, imagine if you had a school system, a grade school, that had, during the day, you had students that would connect to their educational servers, they would connect to Scholastic servers, but after hours, they rent the classroom out to, let's say, an AA meeting. And the AA meeting says, we need internet connectivity, and yet you don't want them on the same network as the rest of your servers, and you're thinking, well, normally you just figure put them on an outside network. But actually, you need to do some firewall changes, because the AA meeting is going to look at how the alcohol industry advertises. And so they're going to want to visit some websites to show that sort of stuff. Yet this is normally blocked at a grade school. So your network actually has to reconfigure for the different business need. And then in the morning, reconfigure back to the normal business need. Other examples would be a stadium, where at noon you have a football game going on, but at 8 p.m. you have one of the biggest rock stars come in, and that network has to change for the purpose of what is being presented in that stadium. So really neat technology as far as being able to just change the network almost at whim, which I think is going to support a lot of businesses where they say, gee, we need a different network, and we need that different network almost overnight. They can make those sort of changes very dynamically.
So, Tim, this is sounding like just a relabeled software-defined network. Well, did the presentations go into what makes it different? And why would an enterprise want this if your network, you think, doesn't change that often?
Well, I think that's the thing that at least I've learned from business is, if you're in business, things change, and they change faster than you're usually prepared for it. There's many situations where all of a sudden your business says, gee, we need to have a different business unit operating here, or we're acquiring another company, and that company needs to come into the fold and be operational within a couple of weeks, not a couple of months, but a couple of weeks. Being able to have a network that changes as fast as the business needs change is really something that I think they were very advanced in their thinking of how to do this. Now, you're right. You're questioning, is this SDN? I would say this is probably the most accurate representation of SDN that at least I believe I've seen. I think over the past years, we've seen a number of different companies say, hey, we're doing SDN, and this is what we believe SDN is. And other companies say, oh, we think SDN is something different. I think this is the first time SDN has been properly defined of a network that will dynamically change to what the needs of the users and the business are as the needs change, instead of just, well, we're going to change routing. It's, you know, what their DNA Center does is it will change routing, it will change policies, it will change security, it will change access lists, it will change QoS. So effectively being able to make any change to the network according to whatever schedule you want, I see that as just, this is really what the industry has been asking for with SDN, and I think Cisco's really nailed it with that definition.
Tim, I've got to ask, when you're talking about doing this with definitions, when you're talking about changing the network at the speed of business, over the past decade, 15 years even, we've heard about more and more things changing at the speed of business. But there's always been something, and to this point, it's generally been the network that was sort of a point of stability around which everything else could change. Do you think that with this kind of option being available, we're out of stability points, or is there something else now around which the business needs can revolve, or do we just have to get used to living in a totally unmoored, all changing, many different moving parts kind of environment?
Well, I think it's that you have, I guess I'm going to describe what they've done as, you can have a large room that has a number of different people using that room at the same time, versus I know everyone has been in a multi-purpose room. Usually this is in a school. You're in a multi-purpose room that they can reconfigure the room to have stadium seating. They can reconfigure the room to say, we're going to have a small stage. We're going to reconfigure the room to have it be a giant circle time where everyone sits in a circle and can meet. Or we'll put gymnastics in here. And I think that's really their take on the network. And you're right, it used to be just one stable, static environment where it works. Now, is DNA Center going to make it so that you have the flexibility? Yes. Is it going to create some strange situations that lose some of the stability? I would also say yes. And the reason is, this is very new technology. You're going to have the system, and I don't mean to diss their technology, but you are going to have situations where people will put a change into place and they're not aware of the effect of the change. And so they figure at 8 p.m. when the classroom changes to support the AA meetings, they're realizing, gee, it didn't change, and so those people can't connect to the network, or it didn't effectively allow them access to their servers or their services. Or you come in the morning and you find some grade school kid that says, ha, look, I can go out and surf the internet and hit Budweiser's website. And so there's going to be some learning about how to make sure it is used effectively and that the bugs are worked out so that you don't have networks change and create problems as a result of either poor administration or it just being a very early on product.
Right. Now, the interesting thing is, come from Cisco Live, do you feel like you've gotten some feedback from attendees and others around potential changes that are required in the system?
Well, so right now, I think there's excitement about this technology, but there's still a lot of trepidation. And my guess is for organizations that have to deal with change on a daily basis, you'll have some larger organizations that say, we don't want to have 70 CCIEs working for our team, modifying our network. We'd like to have a core team of 5 or 10 experts and give them the right tools that they can end up managing and directing and choreographing the network's operation that are going to benefit from this, and they're going to be forced into doing that. Medium-sized organizations are going to hold back and probably watch to see how well does this play out, what are the pitfalls, what are the benefits, and when it's financially viable, they'll jump in. But I think right now we're in early adopter mode.
Right. So what about existing solutions today? So there's obviously people who are using existing solutions today, and now hearing a little bit more about DNA Center and some of the things they're moving forward on. How does this change? Like, what are people's frustrations with the current solutions, and why are they kind of moving on to DNA?
Well, again, the current problem is that you'll have organizations that say, I have a new office to open up, I have new VLANs that I need to assign, this network has to change. And what they'll use is they will use various configuration management tools. We actually have a configuration management tool that we're coming out with in 3 months, so that's going to be part of our package. So configuration management tools are kind of the first step that you need to be able to do those sort of wide-scale configuration implementations. The thing is, though, is that eventually you will get a network that is large enough that configuration change management is still going to be a little bit clumsy for those extremely large networks where you want to make policy changes, you want to make firewall changes, and all of that has to happen in one button press together, rather than saying, I'm going to go out and make this change, this change, this change, and this change, and hope that all of them take and they all match up. And so that's kind of where configuration change management eventually would be outgrown, and you'd need something like DNA Center.
Hey, Tim, so I work on a medium-sized network, and the number of tools that I'm starting to have to gather just to do different things and make changes to the network and find out what's going on is starting to become overwhelming. You were mentioning in a brief email conversation that you're starting to get some feedback from your customers on when is enough too much. What kind of changes are you seeing in that industry?
So on the tool side, really, there's a giant pendulum swing that seems to swing back and forth. I mean, I think sadly all of us are old enough we can remember there was a pendulum swing towards mainframes, and then you had desktops and client server, and then it swung back to light clients, and then it swung back to browsers, and we're kind of in this mode where we have some really powerful browsers. So everything I see in technology is this giant pendulum swing, and what ends up happening is you used to have a lot of different tools, and then people swung over and said, I don't want a lot of different tools. I want one dashboard. The problem with the one dashboard is you're not seeing enough information, and so you're realizing you're blind. And so people go back and say, okay, let's keep one dashboard, one main tool, and then let's pepper around a few ancillary tools that are going to help solve problems. And even then they're saying there's too many ancillary tools. The reason they end up with a lot of ancillary tools is the core part of their primary monitoring package isn't doing enough for them. So they end up needing to get 5 and 6 other tools around the sides just because they don't know enough of what's going on the network.
Hey, how's it going?
I'm doing fantastic. So there's a lot of disruption in the market right now with the fact that companies are moving to containers, and enterprises thinking, hey, like I really need to start scaling my data better and making more sense, maybe even more securing our data. Can you maybe go through, containers are kind of the hotness in infrastructure scaling right now. Are there misnomers here? Are we saving costs with containers? Are we securing our data more? Is that why people are moving more to unikernels and other things?
Yeah, containers get compared to unikernels too often, I think. They're fundamentally completely different beasts, and we kind of contend that containers are even less secure than a basic virtual machine, because even the name container gives you this false sense of security. It's like it's supposed to contain something, but it doesn't contain anything. It's trivial to break out of them. So it's kind of a false dichotomy. But yeah, unikernels are starting to see more attention, especially on the security front, simply because of the inherent operating system defects that they prevent.
Right. So I think maybe just go over a little bit about what unikernels are, just maybe the technology behind them, and kind of if you can maybe compare the difference between that and containers, that'd be helpful.
Sure. Yeah. So at the end of the day, I assume probably most of the audience is aware of a virtual machine, which most of our software is being deployed to today, whether you're public cloud, private cloud, somewhere in the middle with hybrid, whatever you want to call it today. Most of our software is virtualized, and containers kind of take this abstraction further. and they break it up into each different process. Unikernels, on the other hand, at the end of the day, are usually deployed as virtual machines. And so, in our unikernels, there's no Linux running underneath it. There is no Windows running underneath it. It's literally just your program running on top of the hypervisor. And you cannot fork new processes. So shellcode exploits go out the door. Mini remote code execution attacks, they go out the door. It's a single process system, and it's sitting directly on top of the hypervisor.
Right, makes sense. So it's essentially it's a customized version of the OS that you're kind of a la carting based on capabilities. Is that kind of simplifying a little bit?
Yeah, it's a rough vein. What it really is the realization that, if we deploy to, say, Linux today, say it's a web application, we're deploying to a system whose design concepts were largely made in 1969, 1970, roughly 40, 50 years ago. Not much has changed since Ken Thompson and Dennis Ritchie started working on Unix a long time ago. And you have to realize that the systems that they were working on, the PDP-7s, the PDP-11s, these systems cost $500,000 in today's money. And they took up the entire freaking wall behind me. Like, they're huge. So they had to support multiple programs because they had to support multiple users using these computers. But you fast forward today in 2018, when this is being filmed, and we have virtual machines everywhere. Even small companies here in San Francisco, 20-person companies, they'll have like 100 virtual machines that they're managing. And they're splitting these VMs up into one program per VM. And obviously the container abstraction takes that further. And so our question is do we really need a full-fledged general purpose operating system that's filled with security holes serving up these applications? Do we really need to give attackers the ability to run their software on our systems? And unikernels are saying, no, we don't need this capability.
Right. So Google's actually quoted, they have a project, I think it's internally actually, the gvisor project, where they're essentially running containers in isolated VMs. Even some of the VMs have been hardened in some cases to make them more secure. Does this help for containers? Like, does it make it even closer? Or, do you think that they'll just never get to what unikernels are possible doing?
Yeah. So I'm glad you brought this up. gvisor is a really interesting vindication of what we've been preaching. gvisor is Google's own admission that containers are inherently insecure abstractions. Google is on record of saying that any container that they run is already backed by a virtual machine because they don't trust container technology to deal with the security aspect. And gvisor, the way they implement it, there's basically two methods. One, they resort to KVM, which is the hypervisor, of course. Or two, they resort to ptrace, where they intercept every single system call. The problem with the ptrace abstraction is as anybody who knows who's used ptrace before, is that it's incredibly, incredibly slow. Like, so slow that it's simply not a production worthwhile endeavor. So I find gvisor interesting just simply from the fact that Google is saying, hey, we know containers suck, and this is an option if you really care about it.
Right. So let's talk a little bit about the fact, I think there was some call outs, the fact that unikernels tend to run at the ring 0 access to the OS. And that's concerning because that means that they have much lower level access. And if you run some malicious code on there, you're in big troubles. So does this create any more issues for unikernels in that case than maybe containers or just standard VMs?
So I'm glad you brought that up. It's a common criticism that is brought up by various people every now and then. And the criticism that it's running at ring 0 is completely unwarranted, and for a couple of reasons. Number one, if we were deploying unikernels to real hardware, which we aren't, if we were deploying unikernels to real hardware, yes, you have that abstraction to where you can just crash the server, and now you have a crashed server and it's on hardware and all things go wrong. But that concern goes away because we're inside of a virtual machine. So that's one thing. Another thing to think about is like, oh, you're running in ring 0, therefore you must be able to attack other programs on that system. Once again, this concern is completely unwarranted. Why? Because unikernels are single process systems. They only run one program per VM to begin with. And so that concern goes out the window, because we're not like Linux, where you go to Amazon, you go to Google, you boot up a Linux Ubuntu instance, you immediately have 100 programs running, even without you installing a single thing. So unikernels, you boot up that instance, and it's just that one program. If you have a Drupal installation, your PHP interpreter is a unikernel, then your database is a unikernel, and maybe you have a load balancer in front of it. That's a unikernel. So each program is isolated into a VM. So the ring 0 thing, that's just a misconception that people have because they actually haven't utilized the systems yet.
Makes sense. So you kind of talked about this a little bit, about performance and the fact that like unikernels, they do different performance. Now, question is, how different in performance are they for the containers or standard VMs?
Good question. They're ridiculously fast is the answer to it. Some researchers are booting unikernels in about 5 milliseconds. So to kind of tell you how fast that is, Docker, containers boot in about 100 milliseconds. So multiple orders of magnitude faster than a container. And obviously a normal Linux or Windows VM, seconds to minutes, which is just light years slower. So boot time is incredibly fast, but runtime is also much faster. So and one thing to clarify is that there's many different unikernel implementations out there. I can count 10 different unikernel implementations, and not every one is made equally. But generally speaking, since it's a single process system, you start getting rid of this context switching that happens. And there's two forms. There's from kernel to user, back and forth. So we're talking every single packet that comes into your network and every single disk write that hits the disk. That's a kernel to user traversal. And unikernels typically, in most implementations, remove that traversal. This massively, massively speeds up your systems. Microsoft themselves have measured this, and they've said that this costs 30 to 40% performance hit. And it's just something that engineers have to live with because they haven't really dealt with anything else. So that's one form. But then the other form is I spoke that of Linux systems and Windows systems, they have hundreds of programs running. And so it's an illusion. It's an illusion that these programs are actually running at the same time. It's not. They're switching back and forth really, really fast and pretending to run at the same time. And so that's an extra cost that unikernels get rid of. And so you can run things like databases like Cassandra. You can run things like MySQL, Nginx, name the software. It's going to run faster in a unikernel implementation.
Well, folks, now it's time for my favorite part of the show where we get to bring a guest and drop some knowledge on the TWiET Riot. And today is no exception. We have Nathan Pierce, Solution Architect from the Office of the CTO from F5 Networks. Nathan, welcome to the show.
I like the show, and I'm glad I could be a part of it today.
Absolutely. So we have a really great topic to talk about today. That's DevOps. But first, the audience loves hearing about our guests, a little bit about their kind of a journey through technology. Can you tell us, to folks at home, kind of, where you started and how you got to where you're at today?
So I bounced around for a number of years in various places, startups, etc., and then got hooked on F5. And 12 and a half years later, I'm still here. These days, I'm in the office of the CTO, where we're charged with looking further into the future than maybe a normal product team would, to see what's coming, trends both technically and operationally, trends on how people consume and deploy and use technology as well. So I'm closer to the developer advocate side, but our roles do very much transform based on what those trends are that are happening. To give a couple of examples, lately I've been doing a bit of work with GitHub around configuration as code, while also writing some open source telemetry pipeline solutions, how to get lots of rich data out the network into things like Grafana dashboards. Basically cool, fun stuff.
Right, right. Well, I mean, DevOps today is actually a kind of the talk of the town. Organizations are trying to reduce their costs by reducing the impedance between customers receiving a product, supporting them, servicing them, and fixing and kind of rolling out improvements. Now, can you kind of walk us through, some of the advantages of DevOps and, how and if organizations are adopting it?
So, I mean, I guess first to just set the scene that we're all on the same page. Whenever people talk about transformation, the technology transformation was the desire, how quick I could get resources out to their intended consumers. But really, operational transformation is what was needed to make that a reality. And if I'm not transforming people and the way they interact with and look at technology, then there's no way I can really achieve the digital transformations that we're setting ahead of us. So, and this isn't a brand new thing. Like, it was in 2009 when John Allspaw and Paul Hammond got up at the Velocity conference in the Bay Area and said, we're going to do 10 plus deployments a day. And like, people thought they were crazy, and then they explained how. And it was like, it's actually the way they looked at the technology and interacted with the technology that really changed. So that's kind of cool what's happening, and you can see why now that organizations, we have to be more competitive. We can't wait a year or 6 months for a new deployment to then see what the reaction was to that and then work out how we're going to do the next deployment. We need to be testing things all the time and interacting all the time with customers, getting that feedback and working out how we can continuously evolve. And anytime someone asks me to talk about continuous, you should probably count the amount of times I use the word, about DevOps, how many times I use the word continuous, because I get a little bit obsessive about that term.
Right. I mean, if you don't have kind of that continuous service deployment, continuous operations capabilities, continuous kind of quality of service going forward, it doesn't make sense to move to something like DevOps, especially since it potentially could be a culture shift. Now, you guys are kind of talking about something new. This what the concept of called Super NetOps initiative. Can you kind of walk us through that and describe kind of how it's different from DevOps in general?
Sure. So when we started looking at this operational transformation that had to occur, we came at it from multiple different angles. Developers were getting more influence around infrastructure purchasing decisions just because they had to create these continuous delivery pipelines. So we looked at, what would it take to get maybe a software engineer to become an expert in networking? Can we make them interact more with application delivery technology? Or can we take the people at the other end, the networking engineers that have all that domain knowledge, and bring them closer to DevOps? And there was no question about which was going to be the faster route to market, because that domain knowledge that people have accumulated from working for years in the network industry, that's significant. We can't just give someone a few manuals to read over the weekend and suddenly they can replace NetOps. I mean, the networking operations team, they've learned some gnarly routing protocols that are why they're so valuable. So it made far more sense to teach the principles and practices of software engineering, not make them full-on coders, but to teach the principles and practices that make DevOps possible to people who have spent their whole career on a CLI. So that was our approach. It wasn't, we're not an alternative to DevOps. We're about the transition from a couple of decades of an operating practice and making that more compatible with DevOps and the continuous methodologies.
Right. So I think that, what we see a lot of times when we get to organizations that are trying to adopt DevOps, we see kind of a resistance almost between kind of the operations and the development organizations because they don't necessarily communicate the best with each other. And they all have different processes and they all have different systems that they use and different ways of handling things. Do you see sometimes that's also a reason why an organization might be slow to adopt DevOps?
That is a key area. There is definitely some reluctance at our company conference every year, where all our customers kind of fly in. 3 years ago, we asked everyone in the room, like, we had an automation session that I do each year. We asked everyone how they felt about automation. Were they under any kind of pressure? And there was almost a kind of, you're part of the problem, you're making me automate. There was a reluctance and a kind of resistance in the audience we could see quite clearly on their faces. And then 1 year later, it was incredible how much it had changed. We asked everyone who's under pressure from, executive leadership to either automate or get out of the way. And it went from no interaction to 90% of hands up in that session. So that was kind of amazing how that flipped overnight. I think a lot of people maybe did resist for a while, but then it came from like C-level executive, like, no, this is what's happening. Either automate or get out of the way.
Right. So I think one of the interesting things too is that we actually see is that I think you kind of pointed this a little bit in the beginning is, hey, the knowledge might not necessarily be there. So, we might not necessarily know how to code or do things like that or write scripts. So is this kind of super NetOps initiative kind of also teaching or helping network operators, even engineers, how to code? Or is it's saying, hey, we're going to teach you process and you can kind of go figure out the rest?
So that's actually a great question. It is a journey, and it does take time to kind of take these steps. I mean, in the same way that a software engineer is not going to understand BGP from 10 minutes of reading a manual, also the network engineer is not immediately going to be able to create a full automated system from end to end. But what we had to do was close the gap between the two. So the training program, which is free, on demand, online, you literally just sign up with a free account and you start learning. But we teach to begin with just how to do the things you've always been doing via a RESTful API. Like that's step one, is just how to translate your 20 years of habit. Maybe you're younger than me, it hasn't been 20 years, but 20 years industry culture of always using a CLI and just using a REST interface. And then we build on that, and we're like, how to create, not just how to use REST. I think a lot of vendors jumped in early and just went, here's my REST interface, work it out. Well, we go beyond just teaching people how to do things via REST. We teach them sustainable practices, and that's what's key. If you look at the way a developer automates versus someone who just worked out a bit of Python, it's really easy to code yourself into a way that then is unsustainable long term. You will code yourself into a really bad place and never get back out of it. So we took that on board as like a real threat to not us, to the industry. We wanted to bring these people that we've been working with us on this journey, and we've been looking at how we can help them transform. So it was about getting off the keyboard first, off the CLI, but then also getting these methodologies that are second nature to an engineer because they've been brainwashed down that path, and making sure that these people have learned a REST API to do an implementation that won't break later just because we do a slightly different thing higher up in the system.
Right. So the interesting thing too is what we also notice is that sometimes the kind of the concepts or even know where to start is kind of a hard thing. So this is an interesting program to potentially help that. Now it sounds like you guys did a lot of learning from some customers out there. Now are you also providing to some of these organizations who want to come and learn about this some case studies to say, hey, like this is where this organization started and this is how they became successful, and some people have kind of almost like a template to kind of follow?
So we don't have a lot of case studies on this because we haven't tried to own it like it's our thing and it's just for us and just to help our customers. In fact, the entire thing was developed on GitHub. And the training actually started out as a instructor-led program. We had to actually go and be in the classroom and spin up a whole bunch of virtual machines, and we would give a talk at the beginning, and then people go through the labs and we'd help them all. But we did that very intentionally because over the first few months of delivering this Super NetOps training program, anytime someone found an issue or they found something was a little unclear, we would teach them how to do a pull request against the training course. And before their very eyes, they would see that would kick off a CI integration, continuous integration. I think that's number 4 for continuous. They would kick off an integration that would rebuild the entire training portal, and they would see their change. immediately. It would just happen for them. So they became a part of the process. So our list of contributors to this training program is huge. So while I don't, to your question about like case studies and references, we don't have the traditional kind of case study. But if you just look at how many people contributed, to me, that's the biggest statement in itself. The amount of people that got involved and made themselves a part of it as well, like that to me spoke volumes.
Right. So, no, we have seen, you kind of brought this up. You talked about continuous integration. Now, we've kind of seen an evolution in the market a little bit. They talked about moving to agile, and then continuous delivery, and then continuous integration. And that's kind of started that trend. And now kind of DevOps is supposed to modernize those processes if organizations kind of culture shift to that. Are you seeing that, moving to DevOps is been a bigger shift for organizations than just kind of moving to some of these other processes that they've come into the market and have trended through the market?
I totally agree with that sentiment, and it's mostly because it was easier to affect change within a silo, within an operational kind of area. So, for developers to go from one to the other, I mean, there are programs, there are training companies that will come into your organization to help you make that transition. That's all great, but it's within people who understand those concepts, so it's easier for them to grok. But as soon as you start taking people that have had no visibility of these concepts, and we take entire different teams, and in fact, a great way I love to explain this, my first car was a 1972 Ford Escort Mark I, and I would change the engine. Don't ask why I was blowing engines up, but I would change the engine. I could change the gearbox. And I did this from reading a manual. It wasn't online. The manuals weren't even online back then. I went and bought a book, and I made that happen. And now I open the bonnet of the car, the hood, keep forgetting I live in America now, and I have no idea what's going on. And it's probably good I don't try. That's the kind of evolution that's happened. I was in my safe, secure world, and now there's all this technology that is not from my world, and it's not from my experience. So how do I bring them closer together? So DevOps has just shaken up the world for all of us, because it's broken those silos within organizations that previous initiatives didn't. Like SDN didn't break the way a developer did something, whereas DevOps did, because now DevOps is reliant on me as someone who's automating the part of the network to do the right thing, to make it sustainable the way that I've automated and integrated it, so that when they hit commit, it ends up being live and they're getting the results back of that A/B testing, not having to wait and be like, oh, so it turns out that our networking team didn't learn the principles and practices of DevOps, and now we have another outage.
This week, we have Ms. Jamie Thomas, who's responsible for strategy, development, and client experience for IBM's Power mainframe and storage offering. Jamie is general manager. She's responsible, for all kinds of things, including watching the trends that exist around the mainframe space. She also tends to look at what the enterprise needs to be aware of and prepared for in things like AI, cloud, blockchain, and security. Well, Jamie, thanks very much for joining us this week here at TWiET.
Oh, guys, Kurt, Brian, and Brian, thanks for having me as well on a rainy afternoon here in North Carolina. It's great to talk with all of you.
Well, I'm going to start with the first question that most people have, and that is this. Aren't mainframes yesterday's news? Are there really still new deployments going on for mainframes, or is IBM just in the business of caring for an aging group of customers on this one?
Well, I can assure you all and all the listeners that mainframes are definitely alive each and every day, both from an existing workload perspective and, of course, new workload. In fact, our mainframes are running about 30 billion transactions a day, 6 trillion payments a year. And I can tell you, because I own client support, it continues to be busy 24/7 on a continual basis. And certainly, while we're responsible for all the financial systems and airline reservations and all that cool stuff around the world, we do have a lot of clients onboarding new workloads, particularly in the focus of a Linux type workloads, which is an area that we've invested for quite some time.
Well, I do want to get to that whole Linux area with you, but before I do, I have to ask a question. You were talking about the transactions, and mainframes are traditionally transaction processing monsters. I mean, if you really need to move transactions by the boatload, a mainframe's a great way to go. But a lot of the computing news these days has been around analytics. So how are mainframes when it comes to OLAP, online analytics processing, as compared to their traditional OLTP or online transaction processing?
Well, as you said, the strength of the machine is around transactions, of course, in the case of Z14 encrypted transactions, which we increased by 9 times speed factor, if you will. But from a machine learning perspective, where we see the use cases is utilization of the combination of the transaction with the data that's resident on the machine, if you will, to really improve the time to do things like fraud detection at the point of sale, at the point the transaction is really taking place. That combination of the transaction speed with the data that's already on the system and using machine learning techniques allows a credit card organization or whoever you are really to achieve the outcome in the right amount of time. And I can tell you, I'm a shopper. It's one of my big hobbies, and so I test out this capability all over the world on a regular basis. So it does work quite well.
Well, when it comes to these systems, these big power systems now, do you find that most of your deployments are people who are still using the traditional IBM monolithic mainframe operating systems? You mentioned Linux, and I remember a number of years ago looking at what was at that time an IBM Z system as the platform for a Linux farm. Looking at costing out that versus a giant fleet of white box Intel-based machines. Do you really see people using your mainframes as well as monolithic Linux farms these days, or am I missing deployments entirely?
No, absolutely they do. Some of our clients, of course, that have that ZOS base, they'll utilize Linux on 1LPAR perhaps in combination with ZOS. Linux is where you find a lot of those new workloads because that's where all the open source being developed. And once you've done it, open source, one flavor of Linux, of course, it works well on the Z-Linux flavors. And we definitely see clients doing really unique workloads. So our new clients in total, if you're a net new client, it typically is all Linux workload that you're bringing onto the mainframe, and you're using it as this mega cloud, if you will. It does support 2 million containers, for example, in the Z14 form factor. So you get a lot of high availability and resilience without a lot of, additional effort if you're putting in a large cloud Linux environment.
Now, you mentioned something there I'd like to get some clarification on. You mentioned the Z14 form factor. For our listeners who might not be familiar with this, sort of packaging, physically, what are we looking at? What is a Z14 form factor translate to in terms of, data center floor space?
Okay, so this is a standard mainframe form factor in the case of the Z14. When you look at our other version of this machine, we have a machine called a ZR1, which actually is a slim version of the mainframe, and that comes in a standard 19-inch form factor, which is revolutionary for this machine. So you get all the same capability, but in that standard form factor. And in fact, a lot of our new clients, those Linux clients that I mentioned, they're going for that ZR1 form factor, which is that industry standard format. But we have both formats available, depending on what you're trying to achieve with this machine. I would say that even though it's slim, it's still quite heavy. It's got a lot of capability packed into that machine. I think it's still about 2,000 pounds, even in its 19-inch slimness, if you will.
Well, I'm about to give an insight into both my ignorance and my age and ask, when you're doing one of these, do you still have to pipe chilled water into it?
Well, there's different cooling options with these machines, and that depends on what the client desires. So we still have flexibility. And in the case of the ZR1, we met many of the new ASRI standards, of course, for data Center, energy consumption, and all of those things. We spend a lot of time on testing for different compliance algorithms around the world. As you probably know, these things are famous for being earthquake proof and tilt proof and all those wonderful things as well. A lot of our clients do take advantage of that, not only for earthquakes, but construction needs and all these kind of things that are happening in a lot of these emerging cities around the world.
Well, folks, you've sat through another hour of Best Dang Enterprise podcast in the universe, according to 9 out of 10 TWiET episodes. This was the best of TWiET 2018. We hope you enjoyed our year of enterprise goodness. But I do want to also thank some people that helped make the show possible, especially to my co-host, Mr. Brian Chi, who's not only our co-host, but our loyal producer, and also Mr. Curtis Franklin, and of course, our newcomer co-host, experts Brian Mahenry and Heather Williams. We definitely couldn't do the show without them, and I thank them for all their support and knowledge. I want to also thank you, because you make this show possible as well. You are the person that drops each and every week into the show, and we want to make sure it's easy for you to watch and listen for the show. So go out right now to twit.tv/TWiET, where you find all of the episodes, back episodes, our entire year, not only this particular episode, but you'll find all of the full episodes that we've actually showed little snippets for. And of course, next to the show links there, we'll also show you the subscribe links, where you can get the audio version, video version, and HD video version of your choice. You can listen on any one of your devices. It's the best way to stay on top of your enterprise and IT news for the year. So go ahead and subscribe, and also share that subscription with your family and coworkers as well, because we love doing this show and we can continue to do it with your support. Now, also, don't remember, if you're going to subscribe, we also do the show live each and every week at 1:30 p.m. Pacific at live.twit.tv. Come see how the show is run, and if you want to join live, you also can join the chat room live as well at irc.twit.tv. Also, don't forget, you can follow me at twitter.com/LouMM. You get to see what I do during my daily work day and my work week right there on Twitter. And of course, you can also check out dev.office.com. We can see all the latest and greatest productivity improvements you can make on top of your office suites. I also want to thank everyone who makes this show possible, especially to Leo and Lisa. They've given us support for This Week in Enterprise Tech each and every week this entire year, and they continue to give us great support after 2018. So we thank you so much for their support, as well as Mr. Brian Chi, our lawyer producer. He's the one that sets up all these great shows where we got to even pull some of the greats from this year. And so we thank him for his continued support and help in making this show great. And before we sign out, Kevin, do you have a camera on you there? Maybe a dark camera. Okay. Well, at least give a little wave. I want to thank Kevin and and Alex and everybody who's been able to TD this year. Thank you so much for you guys for your support. We couldn't really do the show without you, and you make us look great. And we thank you guys. Happy New Year and happy holidays. Well, folks, until next time and until next episode coming up next year, I'm Louis Maresca saying, if you want to know what's going on in the enterprise, just keep TWiET.